going to happen when you treat these double bonds with an MCPDA in acidic water, right? Now, you just have similar reactions, so this shouldn't be too difficult. But let's just go through step by step. MCPDA is a peroxy acid. So what it's going to do is going to make an epoxide. I mean, we can make an epoxide on the top side, or if you want, we can make an epoxide on the bottom side. So that is a basically 50-50 chance. That will be protonated in the second step because we put it in acidic water. That gets protonated. That makes these two carbon electron division. I mean, these are symmetrical, so these are ideal carbons now get attacked by the water. But the water is going to attack in the backside, not from where the epoxide is formed. It's opposite side where the epoxide is. So since we make the epoxide on the top side, water is making an attack from the bottom side, right? So that makes it transdiol. If the epoxide is sitting on the bottom, water is going to attack to the top side, so you're going to get enantiomers. But still, you're going to get the transdiol. So as long as you make the trans, you will consider the correct answer. So that is basically the first thing that I want to say. And variation we can make to this question, as we talked about. Everything is same. We only change the water to the alcohol, right? The reason why we change that is because we don't want to memorize. Yeah, having an epoxide putting acidic water going into alcohol. You need to be able to follow the mechanisms. So if you follow the mechanism, you know that this is not going to be the water anymore when you're using in alcohol, right? The reason for the change is because we want to see whether you understand the mechanisms. So that's why you got to prepare yourself for a question like this. So it's the same thing. The first step, making an epoxide. Oh, and also I just added the one methyl group there, right? That's going to make a difference as well. Because now these two double bonds are not symmetrical. We got the more substituted side on top, less substituted in the bottom. But epoxide will be created. That's going to be protonated in the second step. Then, because of the oxygen being protonated, pulling the density more from these two carbons. But more substituted side will lose more density than the less substituted side. And the more substituted carbon, that's the one that attacked by the nucleophile, which is an alcohol. Because we do this in alcohol solvent, not water. So alkoxy group is going to be sit on the more substituted side, like this. And then the OH go to less substituted side, right? And then the geometry between these methoxy groups and OH should be opposite trends, right? Because the backside attack. And then what that means is this methyl group sitting on the back has to be pushed forward. Those two gotta be cis. There's a lot of the thing has to be right. And all those changes are made by the mechanism. So why we love to change the question like this, because we want to see whether you understood the mechanism and you follow the mechanism to get to the products. So don't patronizing solving problems and just memorize it. That way, then you're not able to answer this question properly. So very always many more places we can change things. So we have to be careful. This one doesn't matter. This one makes an attack here, this one makes an attack there. They're making the same products. So yeah, even though there was a method groups here, let's say this one goes with this reaction, it's got the same two OHs. So we wouldn't be able to tell which OH is coming from where. So that is a kind of meaningless to make a substitution here. But when they are differently substituted, and then the nucleophile is not the water anymore, then it makes a difference. This is the same question that you just have seen. I just want to repeat that one more time. That makes an epoxide, protonations, and then opening by the water, right? So that's basically what makes a diol. But transdiol. If you do the reaction, that same alkene going through the reaction with the osmium tetroxide, hydrogen peroxide mixtures, or the permanganate, then it will put the two hydroxyl groups there, but those two will be on the same side, right? So I want you to be able to see the differences between these two cellular reagents creating different products, geometry of the products. That also means that you're going to have an enantiomers, which is two hydroxyl groups on the bottom side. But these two are, these meso compounds, these two are basically identical in this particular case. But even though they're not meso compound, you're going to get the enantiomer at the same time. But you're not going to get transdiol using these products. Or you're not going to get cis products using that reagent. So that is basically what you need to be careful.